Hello again, lovely people. Aren't you excited? Good morning, good afternoon. Chapter 7. We're gonna finish. Yes. And if you let me, I'll actually finish this in one single lesson. But considering how many, you're even more whiny than my 1-year-old crying next door. But if you let me, we'll finish this in one lesson. But since you really don't want to, and also let's be honest, we don't have to rush. We're going to split this over a couple of lessons. But there we go. I used to teach this to year 11s in one afternoon. So, it is not that difficult. Here we go. Linear programming, what is it about? Linear programming is about optimization. It's about maximizing functions. So finding the optimal value of a function, not in the sense of P2 or P3 where you're trying to find the maximum or the minimum point of a function. That's not really what we're doing, because here we're dealing with linear functions, so linear straight lines, and because they are infinite, there's no maximum or minimum point, it's just a straight line. What we're trying to find is the optimal solution to a problem given a set of constraints. So I want to maximize, if I'm a business, I want to maximize my revenue subject to my constraints, so my costs. And that's the classic example. I don't know what example to come up with. Typically, this is it, So I'm going to talk through example 1 on page 155 of the book, and then just to how to extract the information that is given in words and translate it into the algebra, and then in a couple of other videos I will talk about how to solve the algebra and how to do that. But here we go. All right, okay. Example number 1, and this is the only one I'm going to do. Here we go. So Mrs. Awan is making cakes to sell for charity. She makes 2 types of cake, fruit and chocolate. I'm not entirely sure I need to read all of it, but maybe. All right, okay. So here we go. So lovely Mrs. Awan is trying to sell cakes for charity. It's a very noble thing to do. I suggest that you do in your life a few things for charity. I've done so myself in the past, so I am talking from experience. It's quite rewarding. I've run 2 marathons for charity. It was painful. You can ask me about it later. But I've raised about £3,000 in charity in those 2 marathons and stuff. And I don't know, I think you should do something nice and give back to the community. Anyway, so apparently each fruit, so we've got fruit cakes. So fruit cake, and the ingredients for a fruit cake are 1 egg, 250 grams of flour, and 200 grams of, that's a lot of sugar. That is a lot of sugar for 1 cake. If you buy one of Mrs. Awan's cakes, you're probably going to have diabetes in 2 days. Then we've also got chocolate cakes. Who doesn't like a good old chocolate cake? So we've got 2 eggs here. 2 eggs. 250 grams of flour. And 300 grams of sugar. Sweet Jesus. Your teeth will be rotting there. Alright. So this is the recipe, and my constraints, so how many cakes can I make? These are my constraints, is the ingredients that I've got. We've got 36 eggs. 7 kilograms of flour. Yep. And 6 kilograms of sugar. I'm not a big fan of sugar. I don't know if you've realized that. I don't like sugar in my tea or my coffee. I'm sweet enough, thank you. Right, and then she's going to sell them. So she's going to sell them. The fruit cakes, because who wants fruit, right? Are cheaper. So these ones go for £3.50, and the chocolate ones go for £5. All right. she wishes to maximize the money she makes from the cakes. All right, so that's going to be what we call my objective function, the function that I want to maximize. I want to maximize my revenue. She wants to make as much money as possible. And you may assume that she sells all the cakes that she makes. This is an assumption that sometimes is not stated in the question, but you assume that. So we're looking for the ideal solution. She may or may not sell them later on when it comes to the sell, but this is what we're working on. We're going to assume that we're going to make as many cakes as possible from these ingredients. We're going to sell them at those prices, and we're trying to figure out what's the optimal combination of fruit and chocolate cakes, right? And it says formulate these in a linear programming problem. All right. Here we go. So, what did you? I'm going to start by defining the objective function. So the profit or the revenue is going to be how much money is she going to make from selling fruit cakes? So well, that's going to be 3.5 f being the number of fruit cakes, plus 5c, c being the number of chocolate cakes. There you go, sorted. That's my objective function. Now I need to figure out the constraints. So what's going to prevent me from doing or making as many cakes as possible? And that's going to be the number of x. So the number of fruit cakes is f times 1 egg per cake, so that's just going to be f plus is 2x per chocolate cake, so 2c. So the number of eggs that we use cannot exceed 36 because we've got only 36 eggs. I assure you that my child is fine, I think. We've only got 36 eggs, we cannot use more than 36 eggs, so the number of eggs that we're going to use is going to, or the number of eggs we're going to use has to be less than or equal to 36, because it cannot be more than 36. The flour that we're going to use is going to be 250 F plus 250 C, has to be again less than or equal to, because it cannot exceed the 7 kilograms. 7,000, because just watch out, I'm sure you've spotted it, but if this is in grams and this is in kilograms, I need to have everything in the same units, and I'd rather not work with decimals out of convenience, find it easier. And then the sugar, well, the same thing, 200 times the number of fruit cakes plus 300 C has to be less than or equal to 6,000. Objective function constraints. There is always another constraint that I don't want you to forget about. It tends to be worth one mark and it's easy to forget, but we assume that actually f is greater than or equal to 0 and c is greater than or equal to 0. That we're going to make a positive number of cakes, because if we were just to look at the maths, mathematically speaking or algebraically speaking, your optimal solution may involve negative numbers, and that doesn't make sense in the real world. So we need to add that final constraint that f and c have to be greater than 0. Okay, and this is just an example of how to take the words and convert them into the algebra, and then we will plot this information on a chart and we will look for the optimal solution, but I will leave that for the next video. There's no point in doing any more of these because each question is going to have different constraints. You just need to do a few or a lot. Get used to reading them. It's lunchtime. I'm gonna finish them. Interpret them, read them, translate them into algebra. Do not forget the non-zero or the non-negativity constraint, and take it from there. So thank you for watching, and I'll see you next time. Bye.